Right. So now if we find out the maximum or the minimum value, so find out y double dash. So what is y dash of x? So that is 1 minus log x upon x square. Now for y double dash, apply u by v form. So what is u by v? So that is v u dash minus u v dash by v squared. That is x to the power 4. Now substitute the point. So that is y double dash of e. Log e is 1. So 1 minus 1, this will be 0. And here x will be going one time. So minus of minus plus. So it is plus e upon e to the power 4. Or that is 1 by e cube. So whatever the value is, but it is greater than 0. So it is positive. I think I made the derivative wrong. Yeah, a mistake from my end. It is v u dash. Right. So y double dash, it is v u dash. Derivative of log is 1 upon x minus u v dash into 2x upon x to the power 4. Now y double dash of e, it will be, x will be going one time. So that is minus e. Log e is 1 by e to the power 4, or that is minus 1 by e cube. So it is less than 0. So then y has which value? Y has maximum value. At which point? At a point x is equals to e. So option A is the right one. Right? And in the same way, here is one more question which was asked in 2012. So here the interval is given. So we are supposed to check out both the global, that means we have to find out the stationary point, like what is f dash? So that is 3x square minus 18x plus 24. And if we equate it to 0, so we can take 3 common. So that will be x square minus 6x plus 8 is equals to 0. So 4 2's. So that is x minus 4, x minus 2 is equals to 0. So x is equals to 4 and x is equals to 2 are the stationary points. And they both lie inside that interval. So that means you are supposed to check out the value of the function at 1, the value of the function at 2 and 4, and as well as 6. Now, among these 3 or among these 4, whichever is the maximum, that will be your required maximum value. Right? Okay. Now, again, in the same way, I have given a few more questions for you to practice. So, this one, directly you can tell. What is its value? Limit extending to infinity 1 plus 1 upon x to the power x.
Sir, this one's option is e power a means e power 1.
Yeah.
Or e.
Yeah, that's it.
Okay, sir. But sir, the formula I have studied this formula today, just 2 hours ago. But sir, it is difficult for me to remember. Means now, okay.
Who is asking you to remember, Srikar? Just follow the procedure. If you apply the limit, what you are getting? We are getting 1 to the power infinity, right? So if it is 1 to the power infinity, then what is your indeterminate form 3? So e to the power limit extending to infinity g of x into f of x minus 1. So individually for each and everything, why to remember when you have a direct procedure for that, x and x will get cancelled. So that is e. That's it. So like that, how many formula you will remember?
Okay, sir. Means I have to follow procedure. Okay, here 1 power infinity means 0.
Not 0. 1 to the power infinity is not defined. It is in indeterminate form 3.
Okay, not defined. So it okay means it is indeterminate form, and I have to use indeterminate form 3.
3.
Use indeterminate form means if I get any question like this, I have to use indeterminate form 3.
That's it.
Okay, sir.
Now
Sir, I
here
want
is
these kind of things more because if, for me it is too hard to remember formulas.
yeah, like
It
to be
is
frank,
100%.
in the class, if you ask me, yeah, Chakrank, after the class, I'm sharing the notes. Even yesterday, I have shared the notes.
Yes, sir. I had also messaged you.
Yeah, didn't I?
Okay. Yes, sir. Yes, sir. You given the notes, sir.
Yeah.
No. Just I had remembered it.
No. Definitely. After the session is over, I'll be sharing the notes with you people.
Okay, sir.
Right. Okay. So again, the maximum value of the function. So just go with the procedure, differentiate once, equate it to 0. You'll get the stationary point. Now check out how many stationary points you are getting. Okay. Like if I differentiate it, f dash, so that is derivative of log 1 upon 1 plus x minus 1 equal to 0. And if you simplify that, 1 minus 1 minus x is equals to 0. So x is equals to 0. Now, as you are getting only one stationary point, right? So then as it is a fill in the blank, directly you can put x equal to 0. Now, if you were getting two stationary points, then you have to go with the double derivative. Okay, so you can reduce your steps in this way. Okay, you can reduce the steps and directly by looking at the stationary point, as it is a fill in the blank, okay, as it is a fill in the blank, then as I'm getting only one stationary point, so that means at that stationary point, it will be having the maximum value. Or if you want to check out, you can check out. What is the double derivative? Derivative of 1 by is minus 1 by 1 plus x whole square. And if I substitute the point, so that is f double dash of 0, which is negative 1. So negative 1 means that is less than 0. So that means f has which value? F has maximum at which point? At x equal to 0. That's it. So why to go with two more steps when I'm getting directly the point here? Okay. Right. Like this, I gave a good number of questions for you to practice. All the previously asked questions. The contour on the xy plane where the partial derivative of x square plus y square with respect to y is equal to the partial derivative of 6y plus 4x. Right? So what is the relation he is asking? Now, if I differentiate partially with respect to y, so this is 2y, and this one with respect to x, so that is 4. That implies y equal to 2. That's it. You see, a simple one, how complicated he has asked. So read the question carefully before you start answering. Okay? Right. And then here again, the interval is given from -100 to +100. And the function is given. First, find out the stationary point and then find out the value of the function at the endpoints and as well as at the stationary point. So you'll be getting a required minimum value. But here, he's not asking the minimum value. Remember, read the question carefully. Okay, so for this function, the minimum value occurs. At which point it occurs, that is what he is asking. He is asking you to find the point where the function is having minimum value. Okay, just as yesterday we have discussed about such type of question. I think that was x equal to 1. And the minimum value was 2. I do remember that. Why? Because we had a good discussion on it. Right. And guys, seriously, have you gone through the PPTs which I have shared to you? Yeah. Have you gone through the PPTs? In the PPTs, I gave you the integral formulae also, so that it will be helpful for us to solve or to learn some questions on today's topic. Okay, in advance, I gave it to you people so that you can or you will read them and you'll try to understand them. Right. And I think I gave around 21 formulae. And I gave the definition of definite integral, or we call it as the fundamental theorem on integral calculus. And again, when I was writing these formulae, okay, so just I need you to remember one more, that is the generalized one, that is the integration by parts. So integral UV. So what is integral UV? UV1 or otherwise U integral V minus integral of U dash into integral V. So this is integration by parts. And we'll be choosing this U and V according to which rule? According to Eilert rule, where I stands for inverse trigonometric, L stands for logarithmic, A stands for algebraic, T stands for trigonometric, and E stands for exponential. Now, yesterday, of course, even yesterday we have discussed about this. Now, what we have discussed in yesterday's class, we were talking about UV form, not UV, indeterminate form 2. Now, when we were discussing about indeterminate form 2, what we have seen? From the bottom, whichever comes first, we have to take it down. But according to Eilert rule, in integration by parts, from the top, whichever comes first, that will be taking it as U. Okay, from the top, whichever comes first, that will be taking it as U. Okay. Now, again, there is one more that we'll be calling it as the generalized UV. So the generalized UV, what it says is integral UV is U V1 minus U dash V2 minus U double dash V3 plus U triple dash V4 minus so on, where V1 stands for first integral of V, V2 stands for second integral of V, and V3 stands for triple integral of V, and so on. Okay, and you can use this generalized UV only under two conditions. If you are having a product of algebraic into exponential, or algebraic into trigonometric. Only under these two conditions, you will be using your generalized UV formula. Okay, right. And again, here, whenever we are writing integral from a to b f of x dx, that always represents the area under the curve y equals to f of x above x-axis between the lines x is equals to a and x is equals to b. Like say if this is a curve y equals to f of x and the area under this curve over x-axis between the lines x is equals to a and x is equals to b. So this yellow shaded area is given by integral from a to b f of x dx. And if you ask me overall, you can find out the integral in 4 ways. So what are the 4 ways of evaluating the integral is? First one is reduction to direct. And the second one is integration by parts. And the third one is integration by substitution method. And the fourth one is by using the properties. And if you are from mechanical and civil, then there is 90% of chance is there to ask a question in what we say in substitution and in properties. 90% chances are there to ask a question on substitution method and properties. Now, when you talk about the substitution, we'll look into 3 cases. Now, what are those 3 cases? So when we talk about the substitution, first, we'll try to substitute the denominator as t, provided the derivative of the denominator, we should get the numerator. If we are not getting, then substitute the numerator as t, provided the derivative of the numerator, I should get the denominator. If we are not getting, and if a function or if we have a function inside another function, that means g of f of x. So close your eyes and directly substitute f of x is equals to t. Okay, like say if I am having e to the power f of x, or if we are having f of x to the power n, or if I am having logarithmic of f of x, and if we are having trigonometric of f of x and so on. Okay, so if I am having a function inside another function, we'll substitute the inner function as t. Okay, and again there is one more function that we called it as the gamma function. And of course, EC and electrical people will be studying about this gamma function in depth. Why? Because your complete communication and your signals and systems are based upon the gamma function only. Now, what this gamma function says is, gamma n is given by integral 0 to infinity e to the power minus x into x to the power n minus 1 dx. And this we call it as the gamma function. And gamma n is given by n minus 1 factorial. And gamma n can also be written as n minus 1 into gamma n minus 1. And gamma 1 by 2 is given by square root of pi. And this one, the problem has been asked for all the branches, like integral from 0 to infinity e to the power minus x square dx. Can anyone tell me what is this integral value? That is square root pi by 2. Okay, just to learn about this particular integral, we people are forced to learn about the gamma functions. And this function in your communication theory, we'll be calling it as what? Yeah, Srikar, sorry, I forgot like where I'm writing. Right. So integral from 0 to infinity e to the power minus x square dx is square root pi by 2. Okay. So in communication theory or in your signals and systems, e to the power minus x square, you call this function as what? Or e to the power minus x square by 2. It is having a particular name. That will be calling it as Gaussian distribution. And without Gaussian distribution, there is no communication theory as of today. So just to learn about this particular integral, we people are forced to learn about the gamma functions. Okay. And again, coming to the properties of your integrals. So the properties of the integrals, if you look into the properties, so the first property, what it says is integral from a to b f of x dx is same as minus integral from b to a f of x dx. So that means whenever we are flipping the limits, okay, whenever we are flipping the limits, then the integral has to be multiplied with negative sign. And again, integral from 0 to a f of x dx is same as integral from 0 to a f of a minus x dx. And as I said, for civil and mechanical, n number of questions were asked on this property. And the extension of this, if you talk about the extension, instead of 0 to a, he might say from a to b f of x dx. That is same as integral from a to b f of a plus b minus x dx. And integral from 0 to a f of x by f of x plus f of a minus x. That is given by a by 2. And the extension of this, that is integral from a to b f of x by f of x plus f of a plus b minus x dx. That is given by b minus a by 2. And whenever we talk about the integral from minus a to plus a, then we'll discuss about even and odd functions. So what are even and odd? So the value of the integral is 0 if f is odd. So what is an odd function? If f of minus x is equals to minus f of x, then we say f of x is an odd function. And in the same way, there is 2 times of integral from 0 to a f of x dx, provided f is even. So if f of x is even function, then the interval will be twice. Twice, or that means twice of the half of that interval. And all these 1, 2, 3, 4, 5, and 6, you can recognize by looking at the limits or by looking at the function. But the seventh property is bit difficult to identify. What it says is integral from 0 to a f of x dx is equals to 0 if f of a minus x is equal to minus f of x. And that is 2 times of half of the interval 0 to a by 2 f of x dx if f of a minus x is equals to plus f of x. So these are the 7 properties of the integrals what you will be having. Okay. And in the same way, so this is all about your integrals. Okay. Now in the same way, when we talk about your double integrals, gamma function, is it hidden? Can't you see this gamma here? Siddharth? Or let me... Still is it hidden? Okay, right.
Sir, I can see gamma function.
Okay. Now, right. So this is about the properties. Now coming to your double integrals. So I don't want to dig into what is a double integral, how do you evaluate this double integral and so on. Okay. Now, I just want to know the methods of evaluating this double integral. Okay. Right. So like if I'm having integral from a to b, integral from y1 of x to y2 of x dx, or f of x comma y dy dx. That means what? If we have functions of x in the limits, if we have functions of x in the limits, then they are what? They are limits of y. They are limits of y. Okay. And first you have to integrate with respect to y, no matter what. That means, like say for example, if I am having integral from 0 to 1, integral from x square to x, some function is there. Okay, so when I am having x in the limits, then they are the limits of y, and no matter what, first I have to integrate with respect to y and then with respect to x. Okay, and if you are referring the textbooks or any of the books, they'll be talking about the vertical strip. Remember this. They'll be talking about the vertical strip. And in the same way, if I am having integral from c to d, integral from x1 of y to x2 of y, some function f of x comma y dx dy. That means if we have functions of functions of y in the limits, then they are what? They are limits of x. They are limits of x. And no matter what, first I have to integrate with respect to x. And if you are referring the books, so they'll be talking about the horizontal strip. Okay. And again, one more important point to be remembered here is, now whenever you talk about double integral over a region, a function f of x comma y dx dy, it always represents the volume. It represents the volume under the curve z is equals to f of x comma y over the region R. Okay, so that means double integral of a function always represents the volume under that curve over that region. And if I'm having double integral without a function, that means dx dy, then it represents the area of the region. Okay, so that represents the area of the region. So whenever we talk about the double integral, so double integral of a function represents the volume and double integral without the function represents the area. Okay, so this is about your double integrals, and the integrals, that part we have seen. Now here is a question. Integral from minus pi to plus pi mod x cos nx dx. 0 if n is even, 0 if n is odd, negative 4 by n square if n is even, negative 4 by n square if n is odd. So it is an MSQ question as for 2 marks. Now here what you have to check out is about the limit. So how the limits are? They are from minus pi to plus pi. That means they are from minus a to plus a. So when the limits are from minus a to plus a, I asked you to check out for the properties. Right, perfect. So what is the property from minus a to plus a? Even and odd, right? So now what type of function is this? Mod x is even, cos nx is even. So even into even, so it is an even function. Now as it is an even function, so then according to the property, what it will be? So that is equals to 2 times of integral from 0 to pi. So from 0 or x greater than 0, mod x will be positive, x cos nx dx. Now here I'm having algebraic into trigonometric. So I'll apply the generalized UV. Now what is generalized UV? UV1, that is x into integral of cos sine nx by n minus derivative of x, that is 1, integral of sine minus cos. So plus cos nx by n square. And the limits are from 0 to pi. So if we apply the limits, so that is 2 times of sine pi or sine n pi is always 0. So what you are having? Cos n pi upon n square minus 0 into sine 0, that is 0, cos 0, that is 1. Right? And that is equals to 2 times of cos n pi value is minus 1 to the power n minus 1 by n square. Right? So now here, as it is MSQ question, now let us say if n is odd. So if n is odd, what happens to the value of the integral? That is 2 times of negative 1 to the power odd is negative 1 upon n square. So the value of the integral is minus 4 by n square. And if n is even, so then the value of the integral is 2 times of negative 1 to the power even, that is positive, and that is equals to how much? 0. So if it is odd, it is negative 4 by n square. And if it is even, then it is 0. So A and D are the answers. Right.
Sir,
Yeah.
that second step once you explain.
Second step.
Sir, cos n pi by n square minus 1 by n square. And after that one step. Sir.
Now I have applied the bounds.
Okay,
Sin
sir.
n pi, upper limit.
Okay,
Sin
sir.
n pi is 0.
Okay, sir.
Cos n pi is negative 1 to the power minus 1, minus n. Now if I am applying the upper limit, sin n pi is 0 and cos n pi I have written. Minus lower limit, 0 into sin 0, that is 0. Cos 0 is 1. Clear?
Yes, sir. Clear.
Right. Now, this is the one which was asked in the year 2015 for mechanical. And it was asked for 2 marks. Integral from 1 to e root x log x dx. Now, you can't write it, Siddharth. You have to calculate in your calci only. Sin pi square by 16, you can't. Right. And remember, you have to type it in radians, not in your regular thing. You have to type it in radians, not in degrees. Okay? Right. Right then. So now, what type of functions we are having? So as we are having the product here, root x log x, right? As we have the product. Now check out. So obviously we have to go with integration by parts, no doubt. Now what type of functions we are having? We are having algebraic into logarithmic, right? So according to Eilert rule, first which one comes? Log value comes. Yes. So here log is u and root x is v. Okay. So this is u and this is v. So apply UV form. So there is u integral v minus integral of derivative of log 1 by x into integral of root 2 by 3 x to the power 3 by 2. And the limits are from 1 to e. And again, if you integrate root, that is 2 by 3 x to the power 3 by 2 log x minus 3 by 2 by x, or x to the power 3 by 2 by x to the power 1, that is x to the power 1 by 2. So x to the power 1 by 2, again its integral is 2 by 3 x to the power 3 by 2. And the limits are from 1 to e. Now if I am applying the limits, so that is 2 by 3 e to the power 3 by 2 log e, that is 1, minus 4 by 9 e to the power 3 by 2. So this is about the upper limit, minus lower limit log 1, that is 0, negative 4 by 9. So 2 by 3 minus 4 by 9, that is 2 by 9, into e to the power 3 by 2 plus 4 by 9. Or if we take out 2 by 9 common, then we are left with e to the power 3 by 2 plus 2. So option B is the right answer. And similar question was asked in 2019, and the question is integral from 1 to e x into log x. Similar question. Here he asked root x log x, but in 2019 without root only x log x. This one was asked for 1 mark and this one was asked for 2 marks. Okay. Right. Now, in 2022, the question is, if f of x is equals to 2 log root over e power x, what is the area bounded by f of x in integral 0 to 2 on x-axis? Right. So one thing we know that the area bounded is given by what? So the area bounded is given by integral from a to b f of x dx. So that means integral from 0 to 2. What is f of x? That is 2 log e to the log root over e power x. Can I write it as e to the power x to the power 1 by 2? And log of a to the power m is how much? M log a, right? And that is 2 into 1 by 2 times of integral 0 to 2 log e to the power x. And log e to the power a is a. And e to the power log a is again a. So log of e power x is x. So finally you are left with only x dx. Integral x, x square by 2. Limits are from 0 to 2. And that is 4 by 2, which is 2 square units. So the function or the question looks complicated. Okay, so question looks complicated. Only thing is you have to check out how to simplify that. Okay. Right. Now. So the value of the integral from negative 1 by 2, negative 1 to 2, integral x square to x plus 2 dx dy. Now I have a simple question. First, with respect to what you are supposed to integrate. First, with respect to what we are supposed to integrate. Are we supposed to integrate with respect to x or y? Perfect. We are supposed to integrate with respect to y. Why? As we have x in the limits, they are the limits of y, and no matter what, first you have to integrate with respect to y. And as you people know, when you are integrating with respect to y, x is treated as constant and vice versa. So integral dy, that is y, limits are from x squared to x plus 2 dx. And that is equals to integral from minus 1 to 2 x plus 2 minus x square whole dx. Now integrate with respect to x, so that is x square by 2 from minus 1 to 2 plus 2x from minus 1 to 2 minus x cube by 3 from minus 1 to 2. And here this is 4 minus 1, which is 3 by 2 plus 2 plus 1, 3. 3 to 6 minus 8 plus 1, 9, which is 3. So 3 by 2 plus 3, that is 9 by 2 is the answer. Right. So this was asked in the year 2017 for electrical. Let I is equals to, can you see the diagram? Yes, okay. Right. So the value of the integral I is equals to. So how to evaluate that or how to integrate it? Right. So first I need to check out the limits. So what are the points here? So this point is 5, 10, and this point is 1, 2. Then the equation of this line is y equals to 2x. Right? Now, if I'm taking the vertical strip, so if I'm taking the vertical strip, then I have to consider the limits of what? The limits of y. So y is varying from where to where? Y is varying from 0 to 2x. And how x is varying? X is varying from least value of x is 1, highest value of x is 5. X is varying from 1 to 5. So then the value of the integral is integral from 0 to 2x. Sorry, first the constant. Integral from 1 to 5. Integral from 0 to 2x. And xy, first you have to integrate with respect to y and then with respect to x. So then that is integral from 1 to 5, x into y square by 2. Limits are from 0 to 2x. And that is equals to integral from 1 to 5, x into, if we apply the limit, so 4x square by 2. So that will be 2x square dx. And that is equals to how much? So that is equals to 2 into integral x cube x power 4 by 4 from 1 to 5. And 5 to the power 4, 25, 25, 625 minus 1 by 2. And there is 624 by 2, which is 312. Right. So the volume under the surface and above the triangle in xy plane defined by. Now, what is the volume? Double integral over r f of x comma y dx dy, right? And that is equals to what? That is equals to limits of x 0 to 12, limits of y 0 to x. What is the function? X plus y dy dx. And that is equals to integral from 0 to 12. So if I'm integrating with respect to y, that is x into y from 0 to x plus y square by 2 from 0 to x dx. Or that is equals to integral from 0 to 12. So this is x square plus x square by 2. So that is 3x square by 2. And integral of x square, x cube by 3. So 3 by 2 into 12 cube by 3. So 3 and 3 will get cancelled. 12 12s 144 times 6. 24, 2, 24, 26, 2, 864. That's it. And seriously, guys, remember, if it is a question in double integrals or triple integrals, think it is a 2 marks question. So far, I have never seen a question in with 1 mark when we talk about double and triple integrals. Each question is of 2 marks. Right. And the targeted audience are EC, electrical, and mechanical. Okay. For triple integral, the targeted audience are electrical, electronics, and mechanical. Okay. Right. So in 2022, this question was asked for EC. So the value of the integral, double integral over D, 3 into x square plus y square dx dy, where D is the shaded triangular region shown in the diagram. Round off to the nearest integer. Right. Now, as the area is symmetric, can we say it is symmetric? So if it is symmetric, can I say that is 2 times of double integral 3 into x square plus y square dy dx, where the region R is in the first quadrant? Yes. So in the first quadrant, if I'm taking the vertical strip, so this line is y equal to x, right? So y is varying from where to where? So y is varying from 0 to x. And how x is varying? X is varying from 0 to 4. Right? So then the value of the integral, 6 times of integral 0 to 4, 0 to x, x square plus y square dy dx. That's it. And you have to integrate this. Yes, Siddharth, you can use the horizontal strip, but you see, if I'm taking the horizontal strip, this curve is what? This curve is y equal to minus x. What are the points, Balaji? What are the points that we are having? 0, 0, 4, 4. When x is 0, y is 0. When x is 4, y is 4. So whatever the value of x is there, right? So then I have considered y equals to x. Yeah, you can consider the full strip. Okay, if we are taking the, or let's discuss in both the cases, what happens. Now, if you are taking the vertical strip or horizontal strip, I have to consider the limits of x, right? So if I have to consider the limits of x, so if I'm taking the horizontal strip here, x is varying from where to where? Y to 4. And if I'm taking the horizontal strip at the bottom, x is varying from where to where? Negative y to 4. So you are getting 2 horizontal strips. So you have to divide the region into 2 parts. So it is a bit complicated. And if you want to take the complete vertical strip, you can take it. No issues in that. So if I'm taking the complete vertical strip, so then how y is varying? Y is varying from negative x to positive x, right? And how x is varying? x is varying from 0 to 4. You'll get the same value. Right, Siddharth? Okay. Right, so integrate this, apply the limits, you'll get your required value. Now again. So in 2023, electrical, 2 marks.
Excuse me, sir.
Yeah.
Sir, regarding the previous question, sir, I have doubts. Sir,
Okay.
in this type, okay, sir, I want to know how I have to solve this type of question, sir, in where integration is given as well as some graph is also involved. Here, triangle is instead of triangles, if I have any other shape like rectangle or trapezoid or pentagon, heptagon, those things.
Remember, if you are not having a shape, like if it is a rectangular, okay, or a square or a parallelogram, so then your limits are constants. Okay, your limits will be the constants. If you are talking about a rectangular or a square shape, always remember that. Okay, and again, okay, right, Farin? Now, if the shapes is given, you see what is the equation or what is the value of y. Okay, if the shapes are given, you have to check out for the value of y. And then maximum take the vertical strip. The reason, if you are taking the horizontal strip, you might get two different regions. Okay, like say here in this example, what we did, if I'm taking the horizontal strip, okay, if I'm taking the horizontal on the top area, I have to consider the values of x. So x is varying from y to 4, right? So that means the horizontal strip is starting on x equal to y and ending on x is equals to 4. Now, if I'm taking the horizontal here, so x is starting on negative y and ending on x is equals to 4. So for one region, you are getting two different strips. Now, when you are getting two different strips for one region, so the best way is check out where you are getting a single strip, where the strip is not at all changing throughout that region. So I'll go with the vertical. Like say, if we talk about this one, okay, say if we talk about this region, now if I'm taking the vertical strip over here, I'll be getting y is varying from where to where? Y is varying from negative x to x plus 2. And if I'm taking the vertical strip here, again y is varying from where to where? Positive x to negative x plus 2. Right? But I'll make use of the symmetric property. Okay. Like as the region is same, as the region is symmetric, so then I'll be going with 2 times of the region. Am I clear? Yes, Srikar.
Sir, I didn't understood what you have told just now regarding this present.
Wow. Right. Now say here, this is the region what you are having. Okay. Now you have to consider the strips. Now which strip you will take? Option is yes, you can take any strip. Either you can take the horizontal, you can take the vertical. So which strip you want to take? Yeah.
Sir, I will take horizontal strip.
Okay, if you want to take the horizontal
Sir,
strip,
horizontal strip.
okay, say if you are taking the horizontal strip here, okay, then you have to consider which limits? Limits of x, right? So x is equals to how much here? Y minus 2. And here, what is the value of x? Minus y plus 2. Right? So if I'm taking the horizontal strip above, x is varying from where to where? X is varying from y minus 2 to negative y plus 2. Clear? And if I'm taking the horizontal strip
Sir,
here,
due to audio issue, I can't hear you properly.
audio issue from my end,
Sir, due to internet instability, here whatever you are speaking, sir, it is getting stopped in between, so I can't hear you continuously.
is it with everyone or only to? Right. Okay. Yeah. So that means you have some internet issues. Yeah, Shrikar? Right. So let's
Sir,
say,
the thing
yeah,
is, internet issue is there, sir. Till I don't know why it is happening.
okay,
Today, from in evening, it was properly working. Just now, it is happening.
okay, right. So if I'm taking the horizontal strip below, x is varying from where to where? Negative y to positive y. So you are getting two different strips. So divide the region into two parts. So the below region I'll take R1 and the above region I'll take R2. Okay. So what is this point? So this point is 1, 1 and this point is negative 1, comma 1. Okay. So then what will be the value of that integral? So first, if I'm taking the first region over R1, xy dx dy plus double integral over R2, right, xy dx dy. Okay. Now, what are the limits of R1 now? So R1 is varying from, right. So R1, what is the vertical horizontal strip for R1? Negative y to positive y. That means this is x. Right. So for R1, x is varying from negative y to positive y. And y is varying from where? I have to check out from here. It is varying from 0 to 1. And for R2, how x is varying? X is varying from y minus 2 to negative y plus 2. And y is varying from 1 to 2. Now you have to integrate this one. Okay, with these limits, you have to integrate it. Or there is one more option. Like as the curve is symmetric, okay, as the region is symmetric, whatever the region is below, the same region is above. Okay. Now, but the curves are getting changed. So what you do is you go with the vertical. Okay. So even with this, you can get it. Nothing to worry. So if I'm going with the vertical, so x is y is varying from x2 minus x plus 2, 2 times of. So another way of solving this is 2 times of integral x is from 0 to 1, y is from x2 negative x plus 2, xy dy dx. No, Vikram. When you talk about the triangle, 4 times of 1/4. Now, when you talk about 1/4 of the part, but the curves were getting changed. You have to be careful with that. Like if I'm taking the below triangle, y is varying from x to 1 only. If I'm taking the above triangle, y is varying from 1 to minus x plus 2. You are getting two different curves. Did you get that one? So I have to include the curves. The curves should be included in it. That is the major thing. Okay. Right. So with these limits, you integrate it, you'll be getting your value of the integral. Right? Am I clear with this? Any doubts so far? All right. And there is one more. I don't know whether, yeah. This one was asked for EC in the year 2019 for 2 marks. Now, the value of the integral. Integral from 0 to pi, integral from y to pi, sin x by x. Now the question is, first with respect to what you are supposed to integrate, x or y? We are supposed to integrate with respect to x, right? Now the question is, do we have the integral of sin x by x? We don't have an integral of sin x by x. Okay. So as we are unable to integrate first with respect to x, what I'll do is I'll reverse the order. That means I'll change the order of integral. And regularly since 2018, continuously a question is being asked in change of order to any one of the branch. For EC or for electrical or for instrumentation or for mechanical or for civil. Any of the branch is just asking the change of order. Okay, continuously is been asking a question on this change of order. And if you are preparing for IIT JAM or if you are writing this IIT JAM exam, again in that there's a model on this. Right. So now as we are unable to integrate with respect to x first, so I'll change the order of integral. So if I want to change the order of integral, what are the limits that he gave? X is equals to y and x is equals to pi. Y is equals to 0 and y is equals to pi. Right. So now, if I plot the region, say this is x and here is y. So y is equals to, sorry, x is equals to y. It is a straight line passing through origin. And x is equals to pi is a line parallel to y-axis. So this is the line x equals to pi. And this is the line x is equals to y. And the points of intersection are 0, 0. This point is pi comma 0. And this point is pi comma pi. Right? So which strip he took? He took the horizontal strip. As y is there in the limits, so they are the limits of x. So he has considered the horizontal strip. So by changing the order, I have to consider the vertical strip. So if I'm taking the vertical strip, how y is varying? So y is varying from 0 to x. And x is varying from where to where? It is varying from 0 to pi. So then the value of that integral will be integral from 0 to pi, integral from 0 to x, sin x by x, dy dx. Now, if we are integrating with respect to y, so integral dy is y, and the limits are from 0 to x. So x will get cancelled. So integral of sine minus cos x from 0 to pi, and that is minus of cos pi is -1, minus cos 0 is 1, and the value of the integral is 2. Sorry, Siddharth, x to the power -1 into sin x. Okay. Now let us say x to the power -1 into sin x. Say if we are going with integration by parts. Okay. Now, what is u and what is v? Let us say if we are having x to the power -1 as u and sin as v. Okay. Now, what is integration by parts? U integral v, integral of sine minus cos, minus integral of, what is the derivative of x power -1? Minus x to the power integral of x power -1. That is log. Derivative, right? So it is minus x to the power -2. Again, integral of sine, that is minus cos. Now again I have to apply integration by parts for this. Now if I go on differentiate x square, the power of x will not decrease. It will go on increasing, -2, -3, -4, -5. It will go on increase and it will not stop. So the integral will go till infinite. So if we are taking sine as u and x to the power -1 as v, so sin x into integral of 1 by x is log x. Right. 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 So integral of 1 by x is log x minus integral of derivative of sine, that is cos, into log x. Now again I have to integrate this, which is a difficult task. So again you have to apply UV form. So that's a never ending one. So you don't have the integral of sine x by x, remember. Okay. Right.
Then how to draw those graphs, sir, in this type of questions?
Graph, like what are the curves that are given, have been given to us? First, x is y, x is pi. Right? So this is x equal to y and x is equals to pi. So x is equals to y is a straight line that is passing through origin. Or let me write to you the direct one so that it will be easy for you people to remember. Now say when you are having x and y square and no constant. So then what type of curve it is? It is a C-shaped parabola. How to solve single integral with dx? Yes, Srinivasulu, I didn't get your question, ma. How to solve single integral with dx? Right. I'll come to your question. We'll discuss. So first, let me explain how the curves are. So if I'm having x and y square and there is no constant, so then it is a C-shaped parabola and it will pass through origin. And in the same way, if I'm having x square and y and no constant is there, so then what type of parabola it is? U-shaped parabola, and it will pass through origin. And if we are having x square and y square and coefficient of x square is equals to coefficient of y square, then what it is? It is a circle. And if we are having x square and y square and the coefficient of x square is not equals to the coefficient of y square, and if they are of same sign, then it is what? It is an ellipse. And if we are having x square and y square and the coefficient of x square is not equals to the coefficient of y square, but it is of opposite signs, then it is what? It is a hyperbola. And if I'm having x and y, only x and y powers, and if I'm having no constant, then it is a straight line through origin. And if I'm having x and y with a constant, then try to convert it in the form of x by a plus y by b is equals to 1, where a represents x-intercept and b represent y-intercept. Based on that, you can plot the curves. Okay, so these are the curves. What type of curves, what is the region that we are having? Based on that, you can plot the curves. Like here, I am having x and y and no constant is there. So when I do not have any constant here, now when no constant is involved there, so it is a straight line that passes through origin, right? So that is what I have drawn here. And x is equals to pi. That means x is equals to constant means it is a line parallel to y-axis. Okay. Now, once these limits are over, then we'll make use of the constant limits to end the region. That means y equal to 0 means it is a line or it is x-axis. So once the region is closed, then we'll find out the points of intersection. Right, Srikar? How to solve single integral with dx, sir, without double integral? Like you mean to say like this or like this without double integral? Yes, Srinivaslu. Was that sin x by x? It depends upon the limits, Srinivaslu. It purely depends upon the limits. Now, if the limits, if you are talking about from minus infinity to plus infinity, there you can integrate it. Like say, if I am having integral from minus to plus infinity or 0 to infinity, 0 to infinity sin x by x dx. If I'm not wrong, are you from civil? ？ Why? Because for civil, this question was asked. Triple E. Oh, 0229, your hall ticket number. Okay. Right. So for triple E, not triple E, for civil, this question was asked. We'll make use of Laplace transform. Now, what is Laplace transform? Right. Let me. Okay. So we'll try to write it as integral 0 to infinity e to the power minus st sin t by t dt, where the value of s is equals to 0. So this is L of sin t by t, where the value of s is equals to 0. So L of sin t by t, division with t is integral from s to infinity L of sin t ds. Now what is L of sin t? It is 1 by s square plus 1 ds. Integral of 1 by s square plus 1, that is tan inverse s. Limits are from s to infinity, where the value of s is 0. Tan inverse infinity, pi by 2, minus tan inverse 0, 0. So the value of the integral is pi by 2. So if we are talking without double integral, sin x by x, its value is pi by 2. Right? Is that clear, Srinivas? Wow. You want me to explain once again, Vikram? Okay. Let me take a new slide. Okay, then. So we want the integral. Yeah. Let me explain clearly. Sin x by x dx. Okay. So what we'll do is, I'll write it in the form of integral 0 to infinity sin t by t dt. It is the same. Only thing is I have changed the variable. Now, I'll write it as integral 0 to infinity e to the power minus st sin t by t dt, where I'll make s is equals to 0. So if I substitute s is equals to 0, e to the power 0, that is 1. So the integral is not getting changed. Now, what is your definition of Laplace transform? Integral 0 to infinity e to the power minus st into f of t dt. This is the definition of Laplace transform. Right? Okay. So now, what is f of t here? F of t is sin t by t. So that is L of sin t by t, where the value of s is equals to 0. Now, in the properties of Laplace, if it is divided by t, then that is integral from s to infinity L of f of t ds. And if it is multiplication with t, then what it is? It is the derivative minus 1 into d by ds of L of f of t. Okay. Multiplication with t, the Laplace property is the derivative. Division with t, the Laplace property is integral. So here I am having division with t, so that is integral from s to infinity L of sin t ds, where s is equals to 0. Now what is L of sin t? It is 1 by or a by s square plus a square, where the value of s is 0. Now integral of 1 by 1 plus s square, that is tan inverse s. Limits are from s to infinity. Now if I apply the limits, so that is tan inverse infinity minus tan inverse. S value is how much we are taking? 0. So tan inverse infinity is pi by 2 minus tan inverse 0 is 0 and the value of the integral is pi by 2. Okay, so if the limits are from 0 to infinity or from minus infinity to plus infinity, then only you can integrate it. Sin t by t or sin x by x. If the limit are finite limits, then you can't integrate sin t by t. Okay. Right, Vikram? Now is that clear? Right then. Now. So the value of double integral over r 10 plus x plus y dx dy, where r is the circular disk, x square plus y square less than or equals to 4. Now, I told you when I was explaining the concept. Srikar, are you there? Or
Yes, sir.
Okay, right. No, you can have for cos x by x also. But for cos x by x, it is difficult. What happens is for cos x by x, integral of s by s square plus 1 you'll be getting. Why? Because L of cos t is cos x by x, which is bit difficult. So what we'll do is, for sine square t by t, you can have it. But cos t by t, you have to subtract with 1. That means you can apply that integral for integral 1 minus sin x or cos x by x. For this, you can find the integral, but not individually for cos x by x. Right, Shibani? Okay. Right then. Now, I told you whenever you are discussing the double integral with a circle, okay, then I ask you to go for what? Polar coordinates. Now, always remember, whenever the region R is a circular region in double integrals, remember that. Go for what? Go for polar coordinates. Now, what are the substitutions to convert it into polar? That is, x is equals to r cos theta, y is equals to r sin theta, and dx dy is equals to r d theta dr. Okay, so these are the standard substitution to convert the Cartesian coordinates into polar coordinates. Now we'll make use of the polar coordinates only when the region R is a circular region. Okay, right. So as we are taking a complete circle, so here theta will be varying from where to where? The complete circle means 0 to 360 degrees. And what is the radius here? X square plus y square is equals to r square we'll be taking. So 4 is 2 square. So radius is 0 to 2. So then the value of that integral will be integral from 0 to 2, integral from 0 to 2 pi, 10 plus x is r cos theta, plus y is r sine theta and dx dy is r d theta dr. Now, if I'm integrating with respect to theta, so 10r into theta from 0 to 2 pi plus r square into integral of cos sine theta from 0 to 2 pi r square into integral of sine minus cos theta from 0 to 2 pi dr. So sine 2 pi is 0, sine 0 is 0. Cos 2 pi is 1, cos 0 is 1. So 1 minus 1, 0. So these two terms are becoming 0 and we are left with only 1. That is 10 times of 2 pi times of integral r square by 2 from 0 to 2. So 2 and 2 will get cancelled. That is equals to 40 pi. Right. So in this, what we have seen is, we have seen conversion of Cartesian to polar. Okay. Right. So now, if we talk in triple integrals, if we talk about the triple integrals, it is same as your double integral. Only few things I want you to remember when we talk about triple integral. So triple integral over V dx, dy, dz, that represents what? That represents the volume of the region. Volume of the region V. Okay. And in your triple integrals, here in double integral, we have seen conversion of Cartesian to polar. But in triple, we'll see conversion of Cartesian to spherical and Cartesian to cylindrical. Now, if we are talking about the cylindrical coordinates, now in cylindrical coordinates, so what are the substitutions we'll be taking? X is equals to r cos theta, y is equals to r sine theta, and z is equals to z. And dx, dy, dz is r d theta, dr, dz. But when it comes to your spherical, it is totally different. So when we talk about the spherical coordinates, we'll take x is equals to r cos theta sine phi and y is equals to r sine theta sine phi and z is equals to r cos phi and dx dy dz is r square sine phi dr d theta d phi. Okay. So these are the spherical coordinates. Conversion from Cartesian to cylindrical, conversion from Cartesian to spherical. Now again, when we talk about the spherical coordinates, for spherical, for a complete sphere, we'll take theta is varying from 0 to 2 pi, but phi is varying from only 0 to pi. Okay. And r is varying from 0 to a, whatever the radius is given. Okay. So you have to be careful. And when you talk in about EC and electrical students, they'll be studying this in electromagnetic theory. again, there you will be learning about the Cartesian coordinate system. So some of your electromagnetic theory faculty or the professors will teach you in this way. Like say they'll be taking in a different way, like x is equals to rho cos phi sin theta. They'll change the angles. Y is equals to rho sin phi sin theta. And rho is equal, z is equals to rho cos phi. They might change or they might write in this way. That means they'll shuffle the angles. But here in this case, phi will be varying from 0 to 2 pi and theta will be varying from 0 to pi. Okay, when you are shuffling the angles, even the rotation of the angle should be changed. Okay, so this is all about your calculus. And with this, I conclude your calculus. Right. So any doubts in your calculus or any topic you want me to revise? Yeah?
No, sir.
Okay. And what about others? Yeah, Farin, you said like you'll be sending me some questions, previously asked questions which you were unable to solve. आपको कुछ दिक्कत हो रहा बोल के बोले थे कल आप. Okay, right.
सर बोल रही थी कि सर मुझे ना कंटिन्यूअस और डिफरेंशिएबल फंक्शन में से थोड़ी प्रॉब्लम हो रही है उसको डिफाइन करने में कि फंक्शन को कंटिन्यूअस और डेरिवेटिव्स कब कहेंगे, मतलब थोड़ा क्लियर है पर कुछ कुछ क्वेश्चन देखते हैं तो फिर सर उसमें बहुत ज्यादा कंफ्यूजन हो जाता है. तो आपको एक क्वेश्चन लेके सर समझा दीजिए उस चीज को.
ठीक है. मतलब आपको कौन सा क्वेश्चन देख के समझ में नहीं आ रहा? वो दैट इज वेरी इंपॉर्टेंट. वो बहुत इंपॉर्टेंट है मुझे. उसके हिसाब से मैं आपको एक्सप्लेन कर सकता हूँ. लाइक अगर मैं कौन सा भी फंक्शन डायरेक्टली लिया तो थोड़ा दिक्कत हो जाएगा आपको भी.
ओके, एक मिनट से मैं आपको क्वेश्चन बताती हूँ.
ठीक है, एक बार क्वेश्चन आप मुझे व्हाट्सएप पे भिजा दीजिए, मैं आपको एक्सप्लेन कर दूंगा. राइट विक्रम? So you want me to explain the mean value theorem? Any particular mean value theorem, Vikram? Or the complete mean value theorems? Only concept, right?
Excuse me, sir.
Yes, speaker.
Sir, in the previous slide,
Mm.
for the cylindrical coordinate, for the cylindrical ones, z equal to what, sir?
Z equals to Z. Z will not change. Why? Because when we are talking about the cylindrical coordinates, for a cylinder, you have the circle at the bottom and at the top, right? Now say if the equation of the circle is x square plus y square is equals to r square, or let us say a square. Okay. Now z is representing what? Z is representing the height. It is not getting changed. And the bottom is a circle. Now when you are talking about a circle, I told you we have to go with the polar coordinates. So the polar coordinates are x is equals to r cos theta, y equals to r sin theta, and dx dy is r d theta dr. So as this z is not changing, it is just representing the height, so it will be as it is. Right?
Okay, sir. Means here there is no change in height. Means there is no involvement of angles in height.
Yes.
Okay, sir.
Right. So that there is no group. Okay. So like the people are sending me the WhatsApp text. I'm reverting back the notes. And Shibani, we are given only 8 hours. That means only 4 classes, out of which by revising only calculus, we took 4 hours. So we will be left with only 2 more classes. That is on Sunday from 4 to 6 and again from 7 to 9. Okay, there I'll be explaining, like, as we are left with only 10 minutes. There I try to explain the concept of linear algebra, only the theoretical concept, no problems will be discussed in that. And the same with the differential equations, only the theoretical concept, how to identify which method, how to solve, and the complex variables. Or is there any particular topic that you people want me to revise? Like, let me write the topics. Like in mathematics, we are having calculus. We are having vector calculus. And we have linear algebra. We have probability and stats. We have differential equations. We have complex variables. And we are having numerical methods. And the Fourier series and the Fourier transforms, Laplace and the Fourier transforms. So now when we talk about CS, calculus, linear, probability, they are having only these 3 topics. And for electrical, the whole thing, except the numericals. Except the numericals, they have everything. Electrical, mechanical, including numericals. EC also, EC, electrical and instrumentation. Except this numerical methods, they are having all the topics. Okay. Right. So you people decide which topic you want me to revise. So on coming Sunday, right. So I think on Sunday, that is 19th, we have 2 sessions. One is from 2 to 4, another one not 2 to 4, 4 to 6, another one from 7 to 9. So we are having 2 sessions. In that 2 sessions, I'll try to explain 3 concepts, 3 chapters. Like when you talk about calculus and vector calculus, these 2 together, you can expect 4 to 6 marks. That's the reason why I have chosen calculus as a first chapter. If you talk exclusively about calculus, you can expect 4 marks only from calculus. And linear, 2 to 3 marks. And probability, 2 to 3 marks. Differential equations, 1 to 2. Complex. And again, when it comes to complex, civil, they do not have complex. And for EC, electrical, damn sure question. And of course, mechanical also a damn sure question on complex. It is also from 1 to 2. Numerical methods, he might ask, he may not ask. Laplace, EC and electrical people will be learning in your signals and systems. So again, in signals and systems, you people are going to study about Laplace and Fourier transforms. Yes, it is there. So weightage for CSC is 8 marks, 7 to 8 marks only from your mathematics. Okay, like CSC, calculus, linear, probability. These 3 together, they'll be given 6 to 8 marks. And the remaining 5, 13. Right. And the remaining 5 to 7 marks or 5 to 8 marks will be from discrete math. Yes, Siddharth, that's my number. Okay. Right. So now, yeah, so we'll see, but linear algebra, probability, we have to discuss. I'll be explaining only the concept. Once again, I'm saying hardly 1 or 2 problems on the properties I might discuss on this linear and probability. And I'll try to go with differential equation, not differential equations, vector calculus. In vector calculus, especially about your, what we say, integral transforms. So integral transforms, that part is there. Okay. You can expect when we talk about mechanical and triple E, you can expect direct 2 marks question on Green's theorem or Stokes theorem or Gauss divergence theorem. You might ask any of the questions. Okay. Right. So now coming to the first question, I think we hardly have 4 minutes. Right. So about the mean value theorems. So what the first or not first, there are 3. First one is Rolle's mean value theorem. Now what this Rolle's mean value theorem says is the statement, if f maps from closed interval a comma b to R is such that f is continuous on closed interval a comma b and f is differentiable on closed interval open interval a comma b and f of a is equals to f of b. So then there will be a point C belongs to the open interval a comma b such that f dash of C equal to 0. Now what this Rolle's mean value theorem says is, if I'm having a curve or a function which is continuous, that means which is defined at every point, and a tangent to the curve is drawn at every point between that interval from A to B, and the curve is at same heights at the end points, then there will be a point C between A and B where the tangent is parallel to x-axis. Tangent is parallel to x-axis. This is what your Rolle's mean value theorem says. And coming to Lagrange's mean value theorem, which is simply called as the mean value theorem, or we can also call it as the first mean value theorem. And for that, we'll take only 2 conditions. F is defined in the interval from A to B such that f is continuous on closed interval a comma b and f is differentiable on open interval a comma b, then f of or f dash of C is equals to f of b minus f of a by b minus a. That means, so we'll not put any condition that the curve should be at same height at the end point. So the curve can be in any shape. Let us say I'll take a curve in this way. And say here is the point A and say here is the point B. Now if I join this point AB, so this point we'll be calling it as a chord. Now there will be a point between A and B where the tangent is parallel to the chord joining the endpoints. Okay. So here the geometrical interpretation is tangent at C is parallel to the chord joining endpoints. So this is the geometrical interpretation of Lagrange's mean value theorem. So the Lagrange's mean value theorem will converge to roles when f of A is equals to f of B. Right, Vikram? Hope I have clarified your doubts. Right.